Okay, here we go. 14e, 2b. We've got root 3 sine x plus cos x equals 1. And you're asked to solve this for x between 0 and 2 pi inclusive, which means you've got to remember you keep your endpoints. So let's have a look. If we do that in the sign, r cos x minus alpha, rearrange it, what are we looking for? Our r equals, now my a is my 1 here, in front of my cos, my b is my root 3, in front of my sine x. So r equals the square root of root 3 squared plus 1 squared, which equals 2. Which means that, here we go, so our cos alpha equals a on r sine alpha equals b over r. So that equals 1/2 root 3 on 2. These keep turning up over and over again. So if we look at over here on a little diagram, sine and cos are positive. Two, that's 1, it's root 3, and that's our alpha. Okay. Therefore, if we look at our inverse cos of 1/2 equals pi over 3. If we pull it all back together, that means that root 3 sine x plus our cos x, well, that equals r, which is 2, times cos x minus our pi on 3. And of course, that equals 1. So now we might be able to solve it, because if I had x, I would just go x equals 1/2. So now I've got 2 cos x equals 1. I can just do that as cos x minus pi over 3 equals 1/2. Which means I'm going to find all the times that values for x between 0 and 2 pi such that they equal 1/2. Now, up here, we used inverse cos. So down here, we might as well use inverse cos as well. So cos to the minus 1 of 1/2 is our x minus pi over 3. So that means that x minus pi over 3 equals, Now we know that inverse cos of 1/2 gives us pi over 3. But you know what? It also gives us this solution down here, because the negative value will also give us, the same thing, because cos of x is the same as cos of negative x, because they're both the same up here. That's the same x value for both points. So that means that we've also got to have a look at x minus pi on 3 equals negative pi on 3, and have a look at the solutions that would yield. Just move that up a fraction. That means we have x equals 2 pi over 3. That's one of our solutions. And because of the fact that we also have, if it's true here, it's also true at this plus pi on 2. So if it's true at x, it's also true at x plus 2 pi and x plus 4 pi and x subtract 2 pi, x subtract 4 pi. So we need to check some of the other ones to make sure whether or not they're solutions. Of course, we're only going between 0 and 2 pi, so really adding and subtracting 2 pi should be enough. Of course, if we add 2 pi to this, we're going to get 8 pi on 3, which is bigger than 2 pi. So if we subtract 2 pi, we're going to get negative 4 pi on 3, which is below 0, which is also outside our bounds. So far we have one solution there. Let's have a look at this side. What does that give us? Well, we have x equals negative pi on 3 plus pi on 3, which gives us 0. Okay, is 0 one of... Now, you've got to be careful with our boundaries. 0 is actually included in our boundary. So that gives us x equals 0 as a solution. Now we've got to check the next one. Well, obviously subtracting anything from 0 is going to be less than 0, but also x equals 0 plus 2 pi equals 2 pi. Now that's a part of our original. Oops. So obviously 2 pi is also included in our solution set. So x equals 2 pi is another solution. So we have solutions x has got to be an element of our set 0, 2 pi on 3 and 2 pi. And there we go.